1.5 hours of stuff for this evening. Should be a good show. So the question is, you have this finite impulse response filter, and what we're being asked is to work out whether it's high pass or low pass, and to work out its -3 decibels cutoff frequency. So in order to do this, we find the magnitude response here, which is found by multiplying itself by itself with an input of z-1 and evaluating all of that at z equals e to the j omega, or I omega if you prefer I instead of j. So you multiply those two together using a bit of blippy bloop algebra, and you end up at the squared magnitude response is half plus half cos omega, which, you know, is pretty cool. So you draw that and it looks like that, and that's quite clearly a low pass filter because this is 1, this is 0. You multiply this by any signal, you are going to get the high frequencies being cut off, you know, multiplied by something that's pretty close to 0. So it is a low pass filter. Now the question is, what is the cutoff? So at what point here do we get -3 decibels, which is around 0.5012? You do -3 equals 20 times log of base 10 of the square rooted of this up here, because we want the not the squared one. Take the half down, so we could have actually skipped that step. Take the half down, divide by 10, raise 10 to the power of everything, and you get this. Take a half off, times everything by 2, and then take an arc cosine, and you end up at omega c, which is the cutoff frequency, is about 0.4992 times pi, or about half pi, which if you look here, yeah, makes sense, doesn't it? Okay.
Their algorithm assigned numbers to nodes in the graph that were purported to be the difficulty of achieving the goal from that particular node.
Psychology evidence that's available, and make new predictions which
It's all good in the hood. I swear the water that comes out of my tap actually makes you thirstier. It's like I'm expecting Jackie Chan to turn up in a suit anytime soon.